Good morning. Today we're going to go over the pre-calculus notes for chapter 1.1 and it's titled Functions. Be sure to print in your first and last name and what period you're in. So one of the first things they're going to ask us to do is to evaluate a function. Evaluate is just a fancy word for plug it in and then simplify it. Okay, so if here's our function that we're given right here, we're just going to take any number that's plugged in here for x and plug it in wherever we find x. And sometimes you're going to have more than one x. So just pay attention to that, and it just means plug it in more than once. All right, so for the first one, we're going to plug in a 3. So the function of 3 is equal to -4 times the 3 squared plus 5. Order of operations says we want to do the exponent first. So 3 squared is 9. Order of operations says we do multiplication next. So -4 times 9 is -36. And then we take the -36 plus 5 and we get -31. Okay, so 3 is considered the input. -31 is considered the output. Right? Number 2, we're going to take a -4 and plug it in. So for the function of -4, we're going to have -4 times the -4 squared plus 5. And now you see why we put parentheses around whatever it is we want to square. Because we want to include that negative sign inside the parentheses to remind us that we're squaring -4, not +4, then taking the opposite of it. Okay, order of operations says we're going to square the -4 first, which is 16. Then we're going to multiply the 16 times -4, which is -69. And then we're going to add the 5. So our output is -59 with an input of -4. All right. For example, number 3, we're going to plug in x plus 2. Notice that there's a variable in this now. Okay, so we're going to plug in the x plus 2 where the x was at. Okay, and now we're done because now we've just plugged it in and we can't simplify it like these. We can't just use order of operations and simplify it. Okay. All right. Now we're going to talk about piecewise defined functions. Okay. So for h of x, now we have 2 pieces. That's why it's called piecewise. So for when any number they give it to us that is less than 0, we're going to use this function. And when they give us a number that is greater than or equal to 0, we're going to use this function. So you just have to pay attention to what number they're asking you to plug in. So here, for the first one, they want us to plug in -2. -2 is definitely less than 0. So we're going to plug it into this one, into this function. So h of -2 is 5 minus the -2 squared. -2 squared is 4, and 5 minus 4 is 1. All right. For the next one, we're going to plug in -1. -1 is also less than 0, so we're using the same function. So we're going to have 5 minus the -1 squared, and -1 squared is 1. 5 minus 1 is 4. Okay. The third one the third number they want us to plug in is 0. Now 0 is here and here. So we want it equal to 0, so we actually have to use this second piecewise function. So we're going to plug it into this second expression, and we're going to have 2/3 times the 0 plus 7. Order of operations says to multiply first, which gets us 0 plus 7, which is 7. All right, for the last one, we're going to plug in, what do they want us to plug in? 3. 3 is greater than 0, so we're going to use the second piecewise function. We're going to have 2/3 times 3 plus 7. The 3's cancel, and we're left with 2 plus 7, which is 9. All right. Now they're going to ask us for the domain of the function. All right, so for number 5, we've got the function of x is equal to the square root of x minus 5. So what do they mean, or what do they want us to do? They want us to say, are there any, or is there any values that we cannot take the square root of. Something that would make this negative, right? Because if you have a negative number under the radical, it's no longer a real number. It's going to be imaginary. So for right now, we need to keep it positive. Okay, so what would keep it positive would be saying that it's greater than or equal to 0. So we're going to take what's under the radical, which is that x minus 5, and make sure that it's greater than or equal to 0. Add 5 to both sides. So the domain is all real numbers when x is greater than or equal to 5. Okay? So the values of that can be input into a function make a relationship. Okay? For number 6, we have a function h of x equal to x plus 7 over x squared minus 9. Is there any value that we cannot divide by right? What can this denominator not be equal to? And the answer is 0. You can't, it's undefined when you have a 0 in the denominator. So we're going to take this denominator of x squared minus 9 and we're going to set it equal to 0. But in this case, we're going to say that it cannot equal 0 because you can't have a 0 in the denominator. So you add 9 to both sides. You do the inverse operation of squaring, which is square rooting. And you can't forget the positive and the negative. So x cannot be equal to positive 3. X cannot be equal to negative 3. And so for the domain, you say all real numbers such that x cannot be equal to positive or negative 3.